Welcome to the deep dive. Today, we're going straight into the heart of a really interesting course, AI prompting for SAT success. It's a 12-module system, and it promises something pretty bold.
It really does. The core idea, and maybe we should just quote it directly, is transforming SAT prep from, scattered practice into a systematic AI-powered mastery system.
Right, systematic, AI-powered. That's the hook. It suggests using AI not just for quick answers, but like as a strategic partner.
Exactly. More than just a calculator or a skill checker. It's about strategy.
So we've looked at different parts of this course before, but today we're focusing entirely on Module 10. This one feels like, well, the grand finale of the strategy phase, the ultimate dress rehearsal.
That's a good way to put it.
Our mission today is to really unpack Module 10. What does this final mock exam look like? And maybe even more importantly, what happens after the test? How does the AI piece work for diagnostics?
Okay. So the module's objective is stated very clearly. Take a full AI-proctored mock exam under realistic timed conditions and perform a deep analysis of the results.
Realistic conditions and deep analysis. That sounds comprehensive.
It is. Module 10 is really the crucible. It's where students have to synthesize and apply all learned content knowledge and AI prompting strategies. Everything comes together here.
So all the earlier modules, the day collection from Module 1 and 2, the strategic thinking, error correction from Module 8, it all gets tested here.
Precisely. Think of it as the final systems check. If a particular strategy or piece of knowledge isn't solid, this is where it's supposed to show up, under pressure.
Okay, let's get into that pressure aspect. Why is a full simulation so critical?
Well, first off, we need to stop thinking about the digital SAT as just, a knowledge quiz.
Right, it's more than that.
It's definitely more. It's a test of endurance, mental stamina, focus management. We're asking students to be on for, 2 hours and 14 minutes.
2 hours, 14 minutes, that's a long time for intense concentration, especially for a high school student.
It is. It's a cognitive marathon. And you simply can't prepare for that kind of sustained effort by doing, 20-minute problem sets here and there.
So sporadic practice just won't cut it.
Not for building this kind of stamina. The course calls the simulation meticulously planned for a reason. It's designed specifically to build that mental and physical resilience.
And presumably to expose weaknesses that only show up under fatigue.
Exactly. You want to see where focus starts to lag. When does test anxiety actually kick in? Does performance drop off significantly in that final math module? You need the simulation to find those fatigue-induced errors.
Because errors made when you're fresh are different from errors made after 90 minutes of intense work.
Totally different. If you don't simulate realistically, the mistakes you analyze later, they might not be the real mistakes you'd make on test day. The analysis loses its value if the input data isn't authentic, isn't captured under fire.
Okay, stamina, focus, fatigue, that makes sense.
Yeah.
But you mentioned the digital SAT. There's something specific about its structure, right? The adaptive part.
Yes. The adaptive nature. This is absolutely crucial.
Why can't I just use a good old-fashioned paper practice test or even a non-adaptive digital one? If the questions are high quality, isn't that enough?
It's not enough because the experience is fundamentally different. The digital SAT works in 2 modules per section, reading, writing, and math.
Right, 2 stages.
And here's the key. How you do on Module 1 directly determines the difficulty level of Module 2.
So if I ace Module 1,
Then Module 2 gets significantly harder. These are the questions where top scores are made. But they also demand more knowledge, sharper thinking, and faster work.
and conversely, if I struggle on Module 1,
If you miss a certain number of questions, Module 2 will be easier, which sounds nice, but
but it caps your potential score, even if you get everything right in that easier second module.
precisely. Let's say you miss, 6 questions in the first math module. You might get routed to the lower difficulty track for the second module. Even a perfect run on that easier track might only get you, say, a 650.
Whereas if I only miss 2 questions in Module 1,
Then you hit the high difficulty track. Now you're playing in the zone where 750s and 800s are possible. But the questions are tougher, the pressure is higher.
wow, so a generic practice test completely misses that dynamic.
Completely. It can't replicate that feeling of the difficulty suddenly shifting based on your performance just moments before. It can't simulate the pacing adjustments needed for a much harder or much easier second module.
You need to feel that shift. Understand the consequences of your Module 1 performance in real time.
Exactly. If you bomb Module 1, how do you adjust? If you nail it, how do you handle the sudden increase in cognitive load for Module 2?
It sounds like the simulation is designed to ensure there are no surprises on test day, as the outline says.
That's the goal. You want the student to have already felt what both the easier and the harder second modules are like, to have practiced pacing under both conditions. That builds confidence and, crucially, informs their strategy. They walk in knowing how the adaptive beast actually behaves.
Okay, so the why is clear. Let's talk about the how. Executing this mock exam. The course is very specific about the tool needed. It mandates the official Blue Book app from the College Board. Why not a third-party simulator, even a really good one?
Yeah, this is presented as non-negotiable, and for good reason. It's about minimizing variables. We want the simulation to be as close to the real thing as humanly possible.
So, interface matters.
The interface matters a lot. The Blue Book app isn't just content, it's the environment, the layout, where the timer is, how the tools function, the built-in Desmos calculator, the reference sheets, the question flagging, all of it.
You need muscle memory for the process, not just the content.
Exactly. If you've trained on software that looks or behaves even slightly differently, you could waste precious seconds on test day just figuring out where things are or how they work.
Little fumbles adding up, like 2 seconds here, 3 seconds there, trying to find the formula sheet.
And on the high difficulty second module, where time pressure is immense, those seconds are gold. Any friction, any extra cognitive load from an unfamiliar interface is just wasted mental energy. We want zero friction on test day.
Okay, Blue Book app it is. Now what about the environment? The protocol around taking the test. The course calls it a controlled environment.
Right. This isn't casual practice. Students are told to treat this like the real deal, like a high-stakes event. First step, block out a full 3-hour window.
3 hours, but the test is only 2 hours, 14 minutes.
Correct. The extra time is for proper setup, getting settled, handling any minor tech glitches without rushing, and having a buffer. It removes the I'm running late stress.
Makes sense. And the rules during the test.
Strict adherence to test day conditions. Phone off and away, no extra tabs open, use only approved scratch paper. And critically, the break protocol.
Ah, the break. How important is that?
Very. The official SAT has a scheduled 10-minute break between the reading, writing, and math sections. This simulation requires you to take that exact break. No more, no less.
Exactly 10 minutes. Why so precise? Couldn't you take, like, 5 if you feel okay, or 12 if you feel stressed?
Because we're simulating the cognitive reset process under time conditions.
Hmm?
10 minutes is designed to be long enough for a quick physical break, stretch, water, restroom, but short enough that you don't completely lose your mental focus, your test zone momentum.
So too long a break and you get cold. Too short and you don't recharge.
Pretty much. Take 15 minutes and you might find it harder to ramp back up. Rush it in 5, and you miss the chance for that brief mental refresh before tackling a completely different section like math. Sticking to the 10 minutes ensures the endurance data we capture is realistic.
It all comes back to authentic data, doesn't it? Apply realistic pressure to generate realistic performance data.
That's the core idea. We need to isolate genuine performance issues, the ones that surface under pressure, from just random, casual mistakes you might make when practicing without stakes.
So the payoff for following this strict protocol.
2 things. 1, the student actively builds that mental and physical stamina required for peak performance. They practice enduring the full test length under rules. 2, and this is vital for the next step, the errors logged during this simulation are the most valuable kind you can get.
Authentic under-fire errors.
Exactly. The kind of errors likely to repeat on the actual SAT if they aren't identified and addressed. This rigorous simulation lays the foundation for the deep analysis that follows.
All right, simulation complete. Students probably wiped out, but they have their score report from Blue Book. Now what? The course says this is where the real learning starts.
Yes, the test itself is only half the module, maybe less in terms of learning value. The quote from the description nails it. A raw score is just a number. The true value comes from a deep analysis that uncovers the why behind your performance.
Moving beyond the number, so getting a 1350 or 1480, that's just the headline.
It's just the starting point. A 700 in math, for instance. Great score, but what does it actually mean? Does it hide a weakness in, say, geometry? Or maybe specific types of algebra problems? Did you ace the easy stuff and struggle with the hard questions, or was it consistent? The aggregate score tells you none of that.
You need to get granular. Look at the individual questions, right? All 98 of them.
All 98 attempted, under-timed, adaptive pressure. And this is where the AI's role becomes, well, indispensable.
Okay, let's address the potential skepticism. Couldn't a good human tutor do this analysis?
Yeah.
Or even the student themselves, carefully reviewing their mistakes? I mean, if I felt rushed, isn't the diagnosis just, you made careless errors due to stress?
A good tutor can certainly help, but the AI brings something different. scale, and objectivity in pattern recognition. A human review can be influenced by the student's own perception. "Oh, I just misread that one," or "I knew how to do it, just ran out of time." Confirmation bias can creep in. The AI, on the other hand, processes the entire data set. Every question, right or wrong, the exact time spent on each one, across both modules, considering the difficulty level assigned by the adaptive algorithm. It's looking for hidden patterns across that massive data set.
Patterns a human might miss. Can you give an example?
Sure, imagine a student misses 8 math questions. A human review might categorize them. 4 algebra, 2 geometry, 2 data analysis. Okay, useful. But the AI might cross-reference timing and question sequence data and find something deeper.
Like what?
Like, all 4 algebra errors occurred on questions immediately following complex reading-writing passages involving historical texts. This suggests a cognitive fatigue spillover effect, where the demanding verbal reasoning depleted mental resources needed for subsequent algebraic manipulation.
Whoa, okay, that's specific.
Or another example. Analysis of timing data shows you consistently spanned over 2 minutes on math questions involving geometric visualization, regardless of difficulty, even though you eventually answer them correctly 75% of the time. This indicates a bottleneck in spatial processing under pressure, costing valuable time needed elsewhere.
That's way beyond review algebra or work on geometry. That's pinpointing the mechanism of the problem.
Exactly. It might identify that you always make calculation errors when inputting a result from the Desmos calculator back into the Scratch work, a transfer error, not a conceptual one. The AI excels at finding these subtle recurring patterns that are incredibly hard for humans to spot reliably across nearly 100 questions.
And that level of specific insight is what makes the feedback truly actionable.
Absolutely. It leads to a highly targeted, last-mile study plan. Instead of broadly reviewing topics, you're addressing specific bottlenecks, cognitive biases, or procedural errors identified by the data. It's precision guidance for that critical final week.
So how do you get the AI to do this? You can't just dump the score report and say, analyze this, right? This brings us to the prompt itself. The course emphasizes using a very specific, structured approach.
Yes, this is critical. It's not just any prompt. It's described as a structured, nested prompt. This is where the AI prompting skills taught earlier in the course really come into play. You're essentially giving the AI a very specific job description.
Job description.
Exactly. You assign it the role of an expert SAT data analyst and coach. That framing is key. It tells the AI how to think and what kind of output is expected.
So it's not just a generic language model anymore. You're constraining it to act like a specialist.
Precisely. Without that specific role and the nested structure detailing the required outputs, you'd likely get very generic advice. Study your weak areas, manage your time better. Useful, maybe, but not deep. This structured prompt is the master key, as the outline calls it, to unlock that actionable, organized, and expert-level feedback.
Let's look at the example prompt provided. I just scored a 1350 on a full practice SAT, 650 rating writing, 700 math. Here is the question-by-question data. Provide a deep analysis of my performance, including timing, error patterns, and 3 actionable recommendations for my final week of study. Okay, that sets the scene clearly.
It does. It gives the overall score, the section breakdown, confirms data is provided, and states the main goals: analysis of performance, timing, errors, and recommendations.
But the real power, you're saying, is in the implied nested structure, the specific things it needs to deliver within that analysis.
Exactly. The prompt implicitly, or perhaps explicitly in the full course materials, requires the AI to break down its analysis into specific components. Let's go through them.
First up, a top-level summary. Why start with that? Seems basic.
It serves a couple of functions. First, it forces the AI to confirm it has correctly ingested and understood the basic score data, the 1350, the 650-700 split. It's a quick verification check.
Okay, like reading back the order in a drive-through?
Kind of, yeah. Second, it anchors the entire subsequent analysis. By stating the overall performance level up front, the AI frames its feedback appropriately. Advice for a 1350 score is different from advice for someone scoring 1100 or 1550. It sets the context.
Makes sense. Next component, skill gap analysis. And specifically identifying the top 3 weakest skills in both reading, writing, and math. Why top 3?
Efficiency. It's about ruthless prioritization, especially in that final week. You probably have more than 3 weaknesses, but which ones are costing you the most points? Which ones are most realistically fixable in a short time?
The Pareto principle, again, focus on the vital few.
Exactly. Trying to fix 10 different small weaknesses in the last week is a recipe for scattered effort and minimal gains. Forcing the AI to identify the top 3 based on the data frequency of errors, difficulty of questions missed, ensures the student directs their limited time to where it will have the biggest impact.
So the output isn't just a laundry list, it's a targeted hit list.
Precisely. They might say, R&W top 3 issues. 1. Inference questions in historical passages. 2. Subject-verb agreement with complex clauses. 3. Interpreting data in informational graphics. Clear targets.
Meant for math.
Maybe. 1. Solving systems of equations using substitution, specifically. 2. Understanding function notation transformations. 3. Calculating probabilities from tables. Again, very specific areas identified as the biggest point trainers in this particular simulation.
Okay, top skill gaps identified. But why are these errors happening? That leads to the next piece. Recurring error pattern recognition. This sounds like the real detective work.
This is absolutely crucial. It moves beyond what you got wrong to how you got it wrong. The AI is tasked with analyzing the mistakes not just by topic, but by the underlying mechanism of the error.
So not just missed algebra questions, but...
Why? Was it conceptual misunderstanding? Did you misread the question? Was it a calculation mistake under pressure? Was it consistently falling for a certain type of trap answer?
The example given in the outline was simple sign mistakes on multi-step problems. Can you elaborate on why spotting that pattern is so valuable?
Think about it. A student keeps missing algebra problems. A basic analysis says weak in algebra. But the AI digs deeper and finds that in 80% of those errors, the student correctly sets up the problem, understands the concepts, but makes a mistake distributing a negative sign in step 2 or 3.
Ah, so it's not that they don't know algebra, it's a specific, repeated procedural slip-up under pressure.
Exactly. And the fix is completely different. If it's a conceptual gap, you review the concept. If it's this specific sign error pattern, the fix might be behavioral, like consciously slowing down for 1 second and physically circling the negative sign before distributing. That's a targeted intervention.
That targeted fix saves potentially hours of unnecessary content review.
Immense amounts of time. This pattern recognition is often the key to breaking through scoring plateaus, especially for students already scoring relatively well. It finds those sneaky habitual errors.
Right, that makes a huge difference. Now let's talk timing, the pacing and timing assessment. The AI analyzes this using standard time per question benchmarks.
Yes, using the average targets. Roughly 1.19 minutes per question for reading writing and 1.59 minutes for math. These aren't rigid rules for every single question. Obviously, some take longer, some shorter.
But they provide a baseline for the AI.
They provide a baseline for the AI to flag significant deviations. Where did the student get bogged down? Did they spend 4 minutes on one super hard math question they ended up missing anyway?
And then maybe rush the last 5 questions as a result.
That's a classic pattern. The AI can quantify it. Analysis shows spending 4 minutes on Q18 missed resulted in averaging only 45 seconds per question for Q21-25. Leading to 2 careless errors on otherwise easy problems.
So it connects the time misallocation directly to lost points.
Exactly. It provides the hard data for the endurance and focus issues we talked about earlier. It shows the cost of poor time management. It allows the AI coach to say, look, your tendency to get stuck on hard geometry, pattern C, is directly causing you to lose points on easier algebra later because you run out of time. Timing issue D.
That connection is powerful. It links behavior to outcome.
Which brings us to the final and arguably most critical output, actionable recommendations. Synthesizing everything, the score, the gaps, the error patterns, the timing issues, into concrete next steps.
And the prompt demands 3 specific, actionable recommendations for the final week, not just general advice.
Correct. Concrete and actionable are the key words. No, try harder, or review math. The AI has to translate its complex analysis into specific instructions a student can actually follow.
Can you give those examples from the source material again? They seemed very specific.
Yeah, they illustrate the point well. So if the analysis showed weakness in inference questions, skill gap B, and slow starts on reading passages, timing D, a recommendation might be, dedicate 3 15-minute sessions this week to AI-generated drills, specifically targeting SAT inference questions. For the first 7 minutes of each drill, prioritize speed slightly over accuracy to combat initial reading inertia.
Okay, that's a specific task, a time limit, a focus area, and even a tactical instruction. Very actionable.
Or for that negative sign error pattern we discussed, error pattern C. The recommendation could be, implement the write-it-down method for all multi-step algebra problems involving distribution. Practice this method for 20 minutes, focusing only on problems similar to Q7, Q12, and Q19 from your practice test, where this error occurred.
Again, a specific behavior change linked to specific problem types identified in the analysis.
These recommendations become the student's personalized study plan for the crucial final days. By demanding 3 concrete, actionable points, Module 10 ensures that the student's final prep hours are laser-focused on activities with the highest potential score yield. It's about targeted correction, not just broad review. Hashtag outro.
Wow. Okay. So this deep dive into Module 10 really shows how it acts as a true capstone. It pulls together everything: the content knowledge, the strategic thinking from earlier modules, the error analysis, even the AI prompting skills themselves.
It absolutely integrates it all. The simulation provides the essential high-pressure data, and the structured AI analysis, driven by that sophisticated prompt, turns that raw data into a clear, actionable roadmap for the final push.
The goal seems to be sending the student into the real SAT feeling prepared, right? Not just with knowledge, but as the course says, with a tested strategy, confidence in your stamina, and a clear understanding of your personal path to success.
That confidence piece is huge. Knowing you've faced a realistic simulation, identified your specific weaknesses, and have a concrete plan to address them in the final days, that's fundamentally different from the usual pretest anxiety and scattered studying.
It replaces guesswork with data-driven direction.
Exactly. And if you look at the bigger picture here, the underlying philosophy is quite powerful. It suggests that real improvement comes not just from learning content, but from mastering the process of self-diagnosis and targeted correction. The course uses AI to teach you how to learn effectively from your own mistakes under pressure.
That really leads to a provocative thought for you, the listener, to consider. If you had limited time before the SAT and could only truly master one module from this course, would you pick a module teaching specific content, like, say, advanced grammar rules?
Or would you choose Module 10, the module that teaches you the process for figuring out exactly where your weaknesses lie and how to spend every single minute of your final prep time for maximum impact?
Something to think about. Mastering that diagnostic process using data to build that custom flight plan?
That seems to be the ultimate value proposition of this module. The deep analysis might just be more critical than any single piece of content knowledge. We'll leave you to ponder the power of that targeted feedback.